4 variable implementation using, I want to use a 8:1 mux now. So implementing a 4 variable Boolean expression using 8:1 mux. So how my mux table will look like? Mux table has 3 variable. No, now as select line. My 3 variable is select line. So I should use B, C, D. B, C, D is your select line, right? And if you have 3 select line, means you have how many data lines? Anyway, madam knows na why to answer. You have 8 data lines, right? 8 data lines, and each data line possibility is 2 possibility, that is 0 and 1. So we will keep our left side as A, right? Now, when A, B, C, D all are 0, 0, 0, D not 1, 2. We can simply keep on writing in the normal order of just number it down, because you all know if you number it like this 1,000,000, if you take this one BCD is 0, 0, 0 and 1, 1,000,000 is 8, 1 and BCD as, okay, if you are new to it you can simply write like this 0, 1, 0, 0, 1, 1, 1, 0, 0. If you are new to it and if you are not remembering, you can write like this. So what you can see, 1,110 will be 14. 0,110 will be 6. Okay, like this. Now let us do the circling. What we should circle? We should circle whatever is there in my minterm group. So let us circle now. 0, 3, 5, 8, 9, 10, 12 and 14. Done, no circling? Now first column. When first column says that 0 and 8 both are circled. If 0 and 8 both are circled, so what should be the answer? If 0 and 8 both are circled?
1.
Yeah, it should be a 1. This one will be, D1 will be?
Yeah.
Yeah, D1, second one is circled, which is your row when A is 1. So this becomes a A. This also becomes a A. This becomes a A bar. This A. This becomes A bar. This one A. And 7 and 15, 0. So we should show the connection also. How do we do the connection? We show that we have a mux function 8:1 mux, D0, D1, D2, D3, D4, D5, D6, D7, right? And we should name it. We should name it. Without naming, it's not complete. So we should name it as D0, D1, D2, D3, D4, D5, D6, D7. And all the connections which is connected to A and A bar, it should be like this. A is getting connected to which all? D1, right? Then D2, then D4, then D6. Like this you have to show the connection. And A bar is connected to only 2. Only 2. So that is D3 and D5. So D3, and you have to show a NOT gate here, and that connects to A bar. So you have to show like this. I have facility of color, so I will use a different color. That is D3 and D5 are connected together and is connected to your A bar. So you get a A bar here. Now 1 and 0, D7 is connected to ground and D1 is connected to 1. You can either write 1 or you can write VCC. Both are same thing. It's better to write 1 only. And you also have to show where your BCD is connected. If you don't show this, it's not complete. Okay? Is it clear? 8:1 implementation is clear? Any doubt with this? Okay, one more. One more means, what if you get a question where they say that you are supposed to implement a max term? What you will do for a max term? So I am asking that you need to implement a max term. You all know, na, max term means what? When these specific variable occurs, that time you should have output as 0, right? You should have output as 0. And when other than these variable occurs, then the output should be 1. How will you implement it? Tell me. How you will implement a max term? Implementing product of sum or max terms. How can
Ma'am, we can ignore the given numbers and circle the ones that are not there. And
so
then,
you can convert the question only, right?
yes, ma'am.
I will convert the question. You all know that minterm and maxterm are complement of each other. So I will convert the question. The question becomes, what all is not there? 1, 2, 4, 6, 7, 8, 9, 10 is there. 11, 13, 14. Correct? Sorry, 15. So 1, 2, 4, 6, 7, 11, 13, 15. This becomes a same question but converted in your implementation form only. Now if you implement this one same as this, if you implement this thing same as this, what will happen? When all these are coming 1, 2, 4, 6, 7, 11, 13, your f will be 1. And when 0, 3, 5 all this is coming, then your f will be 0. That is what you want. No, max term means when this variable comes, output will be 0. When this variable comes, output should be 1. So you know the method of implementing of minterm. So you can convert the question and you can do it. Is this clear to all of you? So we have completed with the design thing. Okay. Now in tomorrow's class, today's quiz question or today's question, I am giving that XOR gate only. You have to just write the connection. What will be D0, what will be D1 and what will be your select line. The way we did for AND gate, you will give me the answer for XOR gate. Okay. Now just to twist the things, I want implement question 6 using 4:1 marks. Implement question 6 using 4:1 marks. Okay.
Ma'am, that XOR gate you should do using 2:1 or?
Using 2:1, na? XOR gate is only 2 input gate, na?
Yes, ma'am.
So you will be using 2:1 marks only. Okay. Now this question number 7. This question number 7 is implementing question number 6 using 4:1 marks. If somebody can do it and share in the class group. Otherwise, let me know, then I will share it in the class group. Implementing question number 6 using 4:1 marks. Okay.